And welcome to another year-end review. Today we're going to be taking a look at units 4 to 6. So unit 4, ladies and gentlemen, is comparing the relationship between quadratic, linear, and exponential, which you can recall we did at the beginning of this. So check your unit 1 review. So make sure you know how to graph it, what the equation looks like, and what happens in the table of values for a quadratic. Also in this unit, we did a bunch of factoring, a bunch of algebra, and then we also did a bunch of solving. So this review, folks, is going to take a little bit longer, but no worries. It deserves to take its time because we spent a lot of time on units 4 to 6. And remember, we probably had a couple unit tests in here, right? Okay, so this is going to be kind of like twice as long for a review, but it covers twice as much of the material. Okay, so please make sure you're ready to go, and if you need to take a pause in the middle of this video, please feel free to do so. All right, folks, the first thing we want to talk about, other than what the equation looks like, what the table of values look like, what the graph looks like, so go back to that unit 1 again, is the forms of the quadratic. Okay, there are 3 different forms. Standard form is y equals ax squared plus bx plus c. And what does this tell us? It tells us the y-intercept. So the y-intercept equals the c value. Okay, so just underline that, c value. Okay, what that does for word problems, folks, that gives us the initial height. If it's a rocket trouble or a rocket problem, okay, or if it's a business model, it gives us the initial startup value. Okay, so whatever you start with, your start value. Next, we're going to take a look at the vertex form, ladies and gentlemen. We spent a lot of time with the vertex form. And it's y equals a bracket x minus p squared plus q. And this gives us the vertex, which is p and q. And when we're taking a look at this, remember, the p equals the axis of symmetry. And the q tells us the min-max optimal value. So remember, folks, if you were asked to find the maximum height of the rocket, that's the q value. Okay? So min-max, the same as that, is called the optimal value. Perfect. Okay? The last form I'm going to take a look at is the factored form. And it's, I'm going to change color, sorry. Got the wrong color there. Pretend that's green. So we're going to go y equals a bracket x minus s bracket s minus t. Okay? And what we need to remember here is that s and t, so you got to remember the negative part in the formula is the formula. So you kind of look at the opposite of what's in the bracket. Okay? So s and t are the roots. Okay? Another word for roots is x-intercepts. Okay, next word, another word for x-intercepts is solutions. And one more word, I know there's a bunch of them, are zeros. Okay, what also is helpful, folks, in standard form is you can find the axis of symmetry. Just going to put this on a side note. Axis of symmetry is going to be x equals s plus t divided by 2. Because zeros, as long as there's 2 of them, okay, meaning the vertex is not on the origin, then s plus t divided by 2 equals your axis of symmetry. Okay, awesome. We spent some time graphing, ladies and gentlemen. I'll go over that. So, ladies and gentlemen, notice what form the equation is given in, and it is in vertex form. So hopefully you realize here that the vertex is 2 and 1. Remember, although it says x minus 2, the negative part is the formula, and the p part is 2. It's all right. I'm just trying to erase this. Okay. So we know the vertex. So on our graph, we're going to plot our vertex at 2 and 1. Okay? So what we need to remember, folks, is how do we tell if this parabola opens up or opens down? Well, it's based on the step pattern, and hopefully you guys remember that the step pattern is a times 1, 3, and 5. Looking at our example given, A is out front, so A equals 1. So therefore, in this case, it's 1 times 1, 3, 5. Hold on, my computer's doing something funny. There we go. Okay. And that equals 1, 3, and 5. So here's how you do your step pattern. Okay, you go over 1, up 1, over 1, up 3, and you would go over 1, up 5 if you had the room. Because it's symmetrical, you do the same on the other side. Over 1, up 1, over 1, up 3. Draw a nice smooth curve. Another thing to double check, folks, is in your equation, you can tell the parabola opens up because A is positive or there's no negative out front. Okay? So what we need to realize is that we need to label this y equals x minus 2 squared plus 1. We've got our arrows. And let's just go over a couple key points. If I asked you for the axis of symmetry from this graph, remember the axis of symmetry is a vertical line that splits the left side to the right side, and it must go through the vertex. So the axis of symmetry, short form is sim, is going to be the equation where it hits the x-axis. So it's going to be x equals 2. If I asked you for the min or max value, you would look at the horizontal value where your vertex is. And in this case, is this a minimum or a maximum? Well, if it opens up, ladies and gentlemen, it goes to the bottom, which is a minimum. Okay? So it's going to be a minimum value of where it hits the y-axis is going to be 1. Awesome. Okay. More to come about the parabola in a little bit. Now we're going to back up and do a bunch of the algebra stuff. So the first thing says to expand, so you're going to use FOIL, which is first, which is 3x times x, which is 3x squared. Okay. Outside, it's going to be plus 12x. Inside, which is going to be negative 1x or just negative x, whichever you'd like prefer. And last is going to be minus 4. Then you look to collect like terms, ladies and gentlemen. And you notice you have two terms in the middle that are common. Okay, so 12x minus 1x equals 11x. And notice, folks, it is in proper order, meaning the highest exponent is first, followed by the least, and going down to the constant. Awesome. Next example says to factor. Remember, there are three main types of factoring. The first type is common. Okay, so that's a term that can be a value that can be divided by all terms. The second is trinomial. And trinomial factoring can be called simple or complex. If it's complex, you're using decomposition. And the third method is difference of squares. Okay, so looking at this example, folks, we have a trinomial. Can we common factor first? No, we cannot. So we must, excuse me. Sorry about that. So first of all, we got to realize that we're doing trinomial factoring. And how do we tell, again, if the trinomial is decomp or simple? Well, you look at A. A does not equal 1. Therefore, we're doing decomp. Okay? So to do decomp, remember the product equals A times C. So the product is going to be 2 times negative 6, which is negative 12. The sum equals your B value, which is negative 1. What two numbers multiply to negative 12 and sum to negative 1? That's going to be negative 4 and 3. And what we're going to do is we're going to split the middle term because it's decomposition. So we're going to decompose that. Hopefully you remember by seeing those arrows. So we're going to write down equals 2x squared, leave the first term there, minus 4x plus 3x, and then minus 6 is still there. Okay? So now you've got 4 terms. Now we factor by grouping. So what's common in the first 2 terms? You're going to have a 2 and an x. What's left over, folks, is going to be x minus 2. Take a look at the last 2 terms. What's common in there? I see a 3, so a positive 3. So what's going to be left over is an x minus 2. Notice now we've got what's called a common binomial. So that goes out front. and our leftovers go in the bracket. So 2x plus 3. Now, ladies and gentlemen, when you do decomposition, there will always be a coefficient in front of at least one of the x's. Okay, and in this case, it's the 2. All right, that was decomposition. Okay, taking a look at the second example, ladies and gentlemen, look to common factor first, and no, we can't common factor. Is it a trinomial? No, it is a binomial. So this is the difference of squares. Okay, so for difference of squares, so you set up two brackets. You put a positive sign in one and negative sign in the other. The reason why you do that is because there's no middle term. It's been eliminated. Take the square root of the first, so square root of 4x squared is 2x. And the square root of the last, square root of 81, is 9. And then, ladies and gentlemen, you have your two binomials there. That is factored. Okay, taking a look at C, ladies and gentlemen. It is a binomial, but we always start with trying to common factor first. So what can we take out? You could say a 2, you could say a 3, you could say a 6, but I would still say you're not right. You need to take a 6 and an x, because x is common to both. So it's going to be 6x is common. So what's left over is x plus 3. Taking a look at D, ladies and gentlemen, look to common factor first. We can't. It is a trinomial because there's 3 terms. So we're going to, and we have to decide if it's simple or complex, meaning decomposition. Look at A. A equals 1, therefore simple. Okay? And remember, when we do simple, it's an easier transfer. There's no splitting of the middle term. So I'll go over that again for those who may be stuck on this. So product equals A times C, but A is 1 in this case, so product is just C, which is negative 72. Okay, and our sum, ladies and gentlemen, equals the middle number, which is 21. Plug this in your calculator, try to figure out what two numbers multiply to negative 72 and sum to 21. And it might take you a bit to do this. This one's a little bigger numbers that we're not used to using on a regular basis. It's negative 3 and 24. So remember, folks, this is simple trinomial factoring. So what you do is you just take the square root of the front, or the first number, and put it in the front of each bracket. And then you take the sign attached to the factor. So it's going to be x minus 3 and x plus 24 in your brackets. Okay. Taking a look at 3. Now 3 says to solve. The difference between example 2 and example 3. Example 2 says a factor. Notice there was no equation, no equal signs, okay, to begin with. In number 3, you have to solve. So you're going to get the variable by itself, okay? So taking a look at this example, first thing I'd look to do is say, hey, is there a number I can divide every term by to make it easier? And yes, you can divide every term by 4. So we're going to have left f squared minus 9 equals 0. Okay, now there's a couple ways you can solve this. I'm going to recognize this as a difference of squares. So I'm going to set up two brackets. And they're going to equal 0. So I'm going to have a plus sign in one and a minus sign in the other. Square root of the first term is f. Square root of the last term is 3. So you have f plus 3 times f minus 3. And here's where you have to use the zero product property, which means how do I get the left side to equal the right side? Because the right side equals 0, so how do I get the left side? What that means is each bracket has to equal 0. So either f plus 3 equals 0 or f minus 3 equals 0. Okay, so f equals negative 3, one answer, or f equals 3 is your second answer. Okay, another way to solve this, folks, on the side, if you like to do it this way, is I'm going to leave my f squared there. I'm going to take my positive 9 and bring it over, sorry, negative 9, bring it over. It's going to become positive. How do I get f by itself? I've got to take the square root of both sides. So if I take the square root of both sides, then f equals, and remember, when you take the square root of a number, we learned it's got to be plus or minus 3. And that, remember, folks, with the communication there, dictates that f equals both positive and negative 3. Awesome. Okay, taking a look at B. For B, ladies and gentlemen, we're going to see if we can divide any term. Can we common factor here first? Or, sorry, is there any term that goes into all terms? We don't really common factor when we have an equal 0 on the right side, but we can divide any term, and we can't. Okay? So in order to make this easier, because we've got a w squared and a w term, we have to get w by itself, we have to get that w so that there's one term there. Okay, so what we're going to do, ladies and gentlemen, is we are going to use decomposition. Okay, so what we're going to do is realize a does not equal 1, so that's why we're using decomposition. Okay, and we're going to try to get them factored. Okay, once we have factors, then we can let each side solve each. I apologize. We can solve each bracket. Okay? So what we need to do is take a look at doing decomposition. So on the margin, we've got a product equals A times C, so 4 times 25 equals 100. Our sum equals our B value, which is negative 20. Okay? What two values multiply to give you positive 100, so they both have to be negative, and sum to give you negative 20. So hopefully you come up with negative 10 times negative 10. Hopefully that didn't take you too long. Okay, but in this case, because it's decomposition, we've got to split the middle term. So we're going to go 4w squared. I apologize, get those equal signs out. Because the equal sign is now with the equal 0. This helps me if I do this first, actually. Okay, so I'm going to go 4w squared minus 10w plus 25. Equals 0. Okay? I look at the first two terms and say, hey, what's common here? I've got a 2 and a w. So what's left over is 2w minus 5. Okay? I look at the last two values and I say, hey, what's in common? I have a 2 and a w, but I'm going to take a negative 2 out so that I have the same binomial left over. So 2w minus 5, and that equals 0. Okay. You need to have the binomials the same so then you can group them, right? So 2w minus 5. Oopsie, I apologize, folks. Instead of taking a 2 out, I think I said 5. If not, I can't remember. Back that up. Sorry, guys. That's a 5. Okay. So I've got 2w minus 5, and what's left over is 2w minus 5, and that equals 0. Well, hey, what do we know about the two of them? They're both the same, so that's 2w minus 5 squared equals 0. Now, to solve this, ladies and gentlemen, we are going to rearrange, because they're the same. We're just going to solve for w. So we're going to go 2w equals 5, and divide both sides by 2. So w equals 5 over 2. Okay, so this is a case, ladies and gentlemen, where there's one answer. What does that mean? That means if I plot this at 5 over 2, which is 2.5, my vertex is there, and A is 4, so it opens up. So that's a case where the vertex is on the x-axis. Likewise, if I move up to the last one we did, folks, okay, we've got solutions where we solve at negative 3 and positive 3, and it opens up. That means our vertex is like that. Okay? Just showing you how you can graph these. All right. Last one here. Ooh, this one has decimals in it. As soon as we have decimals, is it going to be easy for us to use any of the factoring processes? Absolutely not. So what we're going to be doing is we're going to start with the quadratic formula. Okay? And then I might show you a quick fix after. Okay? So since I see decimals in it, I'm going to use quad formula. And it will be provided for you on your final exam. But most of you I know have memorized it. And that's great if you have. Okay? For quadratic formula, it is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay? Now we're going to sub in. We're going to sub in the information we know, but we have to clarify what our values are. So A equals 4.9. Okay. B equals negative 16. But folks, be careful here. What does C equal? We don't see C. So if we don't see a value or a constant, that means C has to equal 0. All right. And instead of using X for my independent variable, in this case, I have a T. So instead of writing X, I'm going to go T equals negative times a negative becomes a positive 16 for the B out front, plus or minus the square root of negative 16 squared minus 4 times A times C, which is 0. Okay. All divided by 2 times 4.9. T equals, simplify a little bit of this, ladies and gentlemen. We're going to have 16 plus or minus. Now look here, something that might be interesting to you instead of having to do a lot of calculations here. The great thing when C equals 0, folks, is that anything times 0 is 0. So that kind of cancels that out. And when you're taking the square, so if you take negative 16 and square it, and then you are taking the square root, you're just going to find that that is 16. Okay? All right. Then you need to break it down into its two cases. Okay? So T equals 16 plus or minus root 16. You could have also put the square root of 16 being 4, guys. That's okay as well. Solve for T. And if you solve this one out, ladies and gentlemen, you're going to get approximately, I apologize. I didn't mean to put the plus or minus sign down. Let's just change that to the plus sign. Sorry, I'm glad you have an eraser with you. Okay, my fault. Sorry. So that's the plus root. Okay. I'm sorry, guys. I forgot something here. I'm sorry, guys. Can we back this up? Here's where you might be confused, and I'm sorry, I didn't mean to do that. So if you take negative 16 and you have negative 16 squared, remember that the square root and the squaring cancel. So instead of having root 16 here, which I had, folks, it's just 16. So the answer simplified before we split it is 16 plus or minus, sorry guys, didn't mean to mess that up, sorry, 16 plus or minus 16. Okay, my fault on that one. Okay, so let's take a look at the two cases. 16 plus 16 divided by 9.8. Sorry, I got lost there. Or the other root is going to be T equals 16 minus 16 over 9.8. Okay, well this one I like. That's easy, that's 0. Okay, plug this one in your calculator, guys. And it's going to get 3.3. So our two answers are either 3.3 or 0. Okay? All right. So another way I could show you folks quickly is what you could have done here as another answer is you could have, in this case, you could have just common factored. Want to know why you can common factor? Because both terms have a t in it. So if I common factor t out, I'm left with 4.9 t minus 16 equals 0. Okay? So in order to get the left side equal to the right side using distributive law, the first t has to equal 0, or 4.9 t minus 16 has to equal 0. So I solve that. 4.9 t equals 16. To get t by itself, divide both sides by 4.9. And in this case, you will get t equals approximately 3.3. Okay? So that's another way you could solve in that case, just because there wasn't a constant value there. All right, folks. Moving on to the second page of the review. If you need to take a quick stretch or a quick break, let me know. Pause the video if you need to. Here we go. For the parabola, y equals 2x squared minus 12x plus 5, determine the optimal value. Well, I always say when you're dealing with some word problems, what form do we have? So in this case, this is in standard form. And what information does it tell us when it's in standard form? It tells us that the y-intercept equals 5. Hopefully that comes to help you out. Okay? Now, optimal value. To find the optimal value, folks, where do you find that? That hits the y-coordinate of your vertex. So you need to have the vertex. So we need to get the vertex P and Q. Okay? And specifically, we need to find the Q part of that. Okay? Now my question is, guys, is how do we get the vertex? We have to convert to vertex form. And hopefully you remember, how do we get to vertex form from standard? Dun, dun, dun. I know it's been a long time, therefore, complete the square. Okay, make sure you know how to do this for your exam, folks. It's a common thing, and you'll do it at the beginning in grade 11. That's my biggest struggle when we first start out in grade 11 is completing the square method. So please make sure you get a good understanding of it now, and life will be easier for you on your exam and next year. All right, so let's take a look. I've got my equation. 2x squared minus 12x plus 5. Step 1, folks, is to get a and factor it of the first two terms. So a equals 2. So you're going to get and factor it of the first term and the second term. The reason why we don't include the third term is because we need to get a perfect square. Okay? We need to get x in terms of one term instead of we've got x squared and an x. Okay, so we leave the 5 out. Now we need to find what's the third term that goes in the bracket that will create a perfect square. So off in the margin, you should remember that you have to take b and divide it by 2. So your b value inside the bracket is -6. So -6 divided by 2 equals -3. Then don't forget we got to go b divided by 2 and square it. So that's -3 squared, which equals 9. That's the number we're going to add and subtract right in here inside the bracket in order to complete the square, which means to get a perfect square here. So I'm going to go y equals 2 bracket x squared minus 6x. I'm going to put that in different colors, so just give me a second. Plus 5. So I'm going to add the 9 in first, and then I'm going to subtract the 9 because you got to keep it balanced. Please note, ladies and gentlemen, the first 3 terms create your perfect square. But what we have to do is we have to separate that from the 4th term. So the 4th term doesn't belong in here, so we've got to bring him out. But when we bring him out, don't forget we got to multiply him by a. Okay, so when we bring him out, and I'll do this in a different color so you can tell. So you take -9 times it by 2, which is going to give you -18, and then you have plus 5. Okay, now we can finish up this in the last line. Y equals 2 bracket. Let's complete the square. So it's going to be x subtract 3 squared. If you forget how that happens, you can quickly do a product and sum there, or you look over here and say, hey, I already wrote that down. That's what it's right there for. Okay, and then collect your constants, and you're going to have -13. So what's our vertex here, folks? Our vertex is 3 and -13. Okay. And the optimal value, we need to decide, folks, if this is a minimum or a maximum. Okay. Well, first of all, it's positive, so it opens up. So you're going to have a minimum of your Q value, which is the second part, or the Y value of your vertex. So it's going to be minimum value of -13. All right. Next thing it says, we want to find the zeros. So to find the zeros, folks, we need to get it into what's called factored form. Okay. And if you find that you're a visual person like I am, what do we know so far? Okay. We now know that the vertex is at 3 and -13, so it's down below. We know that the y-intercept is 5, so it's got to come up like this and do the same on the other side. Okay? So factored form, so for B, we want to find where it hits the the x-axis, okay? So to get into factored form, you want to let y equal 0. So you're going to let y equals 0 because that's how you find your x-intercepts, okay? So we have 0 equals 2x squared minus 12x plus 5. Okay, now that you've got that, you can take a look quickly. I have a product and a sum. So you can try to factor this quickly, or you can simply use the quadratic formula. Remember, the rule is spend 1 to 2 minutes to see if you can factor. If not, go right to quadratic formula. And let's just quickly take a look at that. If you take a look at the product, it's a times c. So that's going to be 2 times 5, which is 10, and sum equals negative 12. Is there any way we can get that to work? No. So you cannot use the factoring form, so that's why you have to use quad form, okay? So can't factor, so you're going to use the quad formula. Okay. So quad formula, you plug it in, we go x equals our b, folks, is negative 12, but a negative times a negative becomes a positive. So you go 12 plus or minus negative 12 squared minus 4 times a times c, all divided by 2 times a. Okay, let's simplify this, folks. Okay, so it's going to be 12 plus or minus the square root. Do the whole thing in the bracket all together. You're going to get 104 divided by 4. We're going to break it up, ladies and gentlemen, into its two cases. So x equals 12 plus root 104 divided by 4. Okay, plug that in your calculator, folks. And you're going to get 5.5. Or do the other root, which x equals 12 minus root 104, all divided by 4. Plug that in your calculator, ladies and gentlemen, and you should get approximately 0.5. Okay, so therefore zeros are 5.5 and 0.5. We expected to have decimal answers here, folks, because we couldn't work out the factoring. All right. Last question here, folks. Oh, sorry, not last question, almost last question. What's the y-intercept? Well, hey, the y-intercept is from what form? Standard form. Do we have standard form already? You betcha, that was given. So look at the y-intercept, which is your c value, and you're going to say y equals 5. Okay? Equation of symmetry, folks. That is x equals p. Okay? So what's your p value from your vertex? It is the first coordinate of your vertex, folks. So you're going to have the equation equal x equals 3. All right, moving on, ladies and gentlemen. Number 2. Okay, for the problem above, describe the transformations. Now, transformations are the shifting left, right, up, down, the stretch or compress, or the reflection of the x-axis. Okay, so to start with, ladies and gentlemen, let's identify our A, P, and Q. So A equals 2, that's going to tell us something. Okay. P equals negative 3, that's also going to tell us something. And Q is going to equal negative 8. So now that we've identified A, P, and Q, let's examine what each letter does. So let's start with A. First of all, A is positive, so it opens up. Otherwise, if it was negative, you would say reflects the x-axis. But A does not equal 1, it equals 2. So your step pattern wouldn't be 1, 3, 5. So instead of that, what happens for your transformations is it stretches, okay? So it's stretched or narrows by a factor of 2. That's because the step pattern is no longer 1, 3, 5. Okay, it's twice as much. Okay, so it's going to make it more narrow. So you could say stretch by a factor of 2 or narrows by a factor of 2. All right, the next one, ladies and gentlemen, is P. P is your left-right shift. Okay, and if it's negative, you're going to the left. So you're going to shift left 3 spots. Okay? All right, taking a look at your Q. Your Q is -8. That's your up-down movement. Okay, since it's negative, you're going down. So this tells us to shift down 8. Okay? Ladies and gentlemen, if you plan to take grade 11 functions, which is grade 11 university math, we do this shifting left, right, up, down, and stretch and compress with all different types of functions. So you'll learn 5 or 6 new ones that you're going to apply this to. All right? So please make sure, it's good to have a good understanding now. All right, last question. Write it in standard form and in factored form. So first of all, what form of the quadratic is it given in? It's given in vertex. So to get from vertex to standard, let's do that one first. Okay, to get to standard form, you just simply expand. Okay. So to expand, I'm going to write it out. Oh, just give me 1 second. Okay. I'm just going to write it out first so I can see it and then go from here. All right. So remember, you have to use BEDMAS, ladies and gentlemen. So I'm going to deal with, within the brackets, I can't do anything, so I'm dealing with the exponents. So remember, you got a binomial squared. I'm going to square the first, which is x times x squared. Double the product. So what's 2 times x times 3? So that's going to be 6x in the middle. Okay. And then I'm going to square the last. So plus 9, and then don't forget minus 8. On a side note, folks, you may on a margin go like this. X plus 3 times x plus 3. Expand and use FOIL, so you could go x squared plus 3x plus 3x plus 9, and then collect like terms, and you'll be exactly where I am there. Okay? So a side note, if you need to expand it out. Okay? Now, we need to do distributive law, so we're going to multiply the 2 into everything in the bracket. So we go y equals 2x squared plus 12x plus 18, and then don't forget your minus 8 out front. And last step is to collect your constants. So you should end up with 2x squared plus 12x plus 10. So that was the standard form, okay? Now the factored form, okay? It's hard to do factored form from the vertex. It's easier to do it from standard form. So I'm going to put that down here. Easiest from standard. Okay, so I'm going to rewrite my standard form, which is the answer you just wrote down. Okay, now I'm going to factor it. Okay, to get it to factored form. So I'm going to common factor out of 2, folks. So 2 bracket x squared plus 6x plus 5. Okay, then I notice that I have a common, I've got a trinomial inside the bracket, so I need to figure out what I'm going to put in there. It is simple because a equals 1. So product equals 5. Sum equals 6. What 2 numbers? Hopefully you have 2 and not 2 and 3, because that gives you a product of 6. I apologize. Sum of 6. I said that wrong. Product of 5, sum of 6. So that's going to be 1 and 5. My fault. Okay? So because it's simple trinomial, take the square root of the first term and take the signs attached to those factors. And there you have it, ladies and gentlemen. That is in factored form. I know that was a long review, folks, but hopefully you found it helpful. And please see me if you need any help. Have a great day and happy quadratic formulaing. Woohoo!